time feels obvious. It feels like the most basic structure of reality. Moments move forward. The past is gone. The future has not arrived. We live in a narrow slice called the present, constantly advancing from what was to what will be. We rarely question this. Time feels too fundamental to doubt. Physics does not agree. At the deepest level of reality, time may not behave the way we experience it. In fact, it may not exist in the way we think it does at all. For most of human history, time was treated as absolute, a universal clock ticking uniformly across the universe. Events happened in a clear order. Cause came before effect. The past created the present, and the present shaped the future. This view felt unbreakable. Then, physics began to look closer. Einstein showed that time is not universal. It slows down with speed. It stretches in strong gravity. Two observers can disagree about how much time has passed, and both can be correct. Time, once thought to be rigid and objective, became flexible and relative. But relativity still preserves something important. Even if time bent, it still existed. There was still a past, a present, and a future. They were just observer-dependent. Quantum physics goes further. At the quantum level, reality stops behaving like a sequence of events unfolding in time. Instead, it behaves like a system of probabilities, correlations, and relationships that do not always respect classical order. Particles do not follow single paths. They exist in superpositions. They are not here or there, but both. And crucially, their properties are not always defined until they are measured. This already challenges the idea of a fixed present. But it also raises a deeper problem. If properties are not defined until measurement, what does that say about the past? In classical thinking, the past is settled. Whatever happened has happened. Quantum physics does not always allow this certainty. In some experiments, quantum systems behave as if their earlier states depend on how they are measured later, not because the past is changed, but because it was never fully determined to begin with. This sounds impossible because it clashes with intuition. We assume the universe keeps a complete record of itself, that every moment leaves behind a definite history. Quantum mechanics suggests that this may not always be true. At fundamental scales, the universe may not store a single, objective timeline. It may only preserve consistency. This leads to a disturbing idea. The universe may care less about what happened first and more about whether the overall story makes sense. To understand this, we need to question something even deeper. What is time actually doing in physics? In the equations that describe reality, time does not flow. It does not move forward. It does not pass. It is treated as a coordinate like space, a label that allows us to describe change, not something that changes itself. There is no equation that describes the motion of time. This creates a paradox. If time does not flow in the equations, why does it feel like it flows in experience? One common answer is memory. We remember the past, but not the future. This asymmetry creates the sensation of motion. We feel time moving because our memories accumulate in one direction. But memory alone is not enough. A recording device also stores information, but it does not experience time. Something deeper is happening. Physics suggests that the arrow of time comes from entropy. Disorder increases. Systems evolve from ordered states to disordered ones. This gives time a direction. But entropy does not erase the past. It only makes it harder to reconstruct. Information spreads, but it is not destroyed. This raises an unsettling possibility. The past may still exist, not as experience, but as information embedded in the present state of the universe. If information is conserved, then every moment leaves a permanent imprint, not in a timeline that recedes behind us, but in the total structure of reality. From this perspective, the past is not gone. It is inaccessible. Quantum physics strengthens this idea. At the quantum level, systems become entangled. Information about one part of the system is distributed across many others. Over time, this information becomes impossible to retrieve, but it still exists. Nothing truly disappears. It only becomes unreachable. If this is true, then time is not a river carrying moments away. It is a static structure where change is a pattern within it. Some physicists describe the universe as a block. Past, present, and future all exist simultaneously. There is no objective now. The present is simply the point along the block where consciousness happens to be. In a block universe, asking where the past went makes no sense. It is still there, just not where you are. This idea feels deeply counterintuitive because it contradicts experience. We feel time passing. We feel the present updating. We feel the future approaching. Physics does not deny these feelings. It suggests they may be emergent. From inside the block, motion feels real. From outside, nothing moves. Quantum physics complicates this picture further. In a block universe, everything exists. But quantum mechanics introduces uncertainty. Outcomes are not fixed. They emerge probabilistically. How can a universe where everything exists also be uncertain? One answer is that the block is not a single fixed structure, but a collection of possible structures. Multiple consistent histories exist, and what we experience is one path through this landscape. In this view, the past and future are not illusions. They are selections from a space of possibilities. The present is where these possibilities become correlated with us. This suggests that time is not fundamental. What is fundamental are relationships between events. What we call past and future are ways of organizing these relationships from a limited perspective. The illusion is not that time exists. The illusion is that it flows. From the universe's point of view, nothing moves. From ours, everything does. As we approach 2026, these ideas are no longer just philosophical. They influence how we think about causality, free will, and reality itself. If the past still exists, and the future already exists, then cause and effect are not simple chains. They are constraints within a larger structure. This does not mean the future can influence the past in a simple way. It means both must fit together coherently. Quantum experiments that seem to show future measurements affecting past behavior may be revealing this deeper consistency. The universe does not allow contradictions. It does not care which direction time points as long as the overall pattern remains consistent. This reframes the mystery. The question is not whether the past exists or whether the future is written. The question is whether time itself is something the universe experiences or something only we do. Our brains evolved to navigate change. We experience events sequentially because that is how survival works. The universe does not need this perspective. Time may be a feature of consciousness interacting with a static or probabilistic structure. This does not make time unreal, it makes it local. Just as temperature is real, but only meaningful for large systems, time may be real, but only meaningful for beings like us. At the deepest level, reality may be timeless, not frozen, but complete. In such a universe, the past and future are not places you travel to. They are parts of a structure you move through. The illusion is not that time exists. The illusion is that it is fundamental. Physics has not yet unified quantum mechanics and gravity. When it does, time may change again. Some approaches to quantum gravity suggest that time disappears entirely from the fundamental equations. If this is true, then time emerges only when the universe becomes complex enough to observe itself. We are not moving through time. Time is emerging through us. The past feels fixed because it is encoded. The future feels open because it is not yet correlated with us. But both may exist in a deeper sense. In 2026, physics does not have a final answer, but it has already shown that time is not what it seems. The mystery is not how time flows. The mystery is why we experience it at all. Perhaps time is the way a timeless universe feels from the inside.